that statement, actually. So by producing the quantity where the revenue generated by the last unit produced is just equal to the cost of that last unit. That is the holy grail of business and profit maximization. We also learned that if you do that, you might not be making any money. But what's true about the money you're losing? It's minimum. It's the least amount of money you could be losing. So this always works for getting you into the right position. As long as something else holds, which is what we're going to get into today. Remember Jack Daniels? I kind of started us down the path of dear old Jack. And let me try to restart this thing. So we got Jack Daniels. So recall Jack Daniels Corporation, where we had total cost of $130,000. We had total variable cost of $50,000. And this, you don't have to repeat this if you don't want to, although it's pretty deep back in your notes. You might want to put the summary up here, but we spent a little more time on it last time. The total fixed cost was $80,000. And then we calculated the average total cost, average variable cost, and finally average fixed cost. Assuming that this was going on at 10,000. So assume Q star equals 10,000, 10,000 units now, 10,000 units, 10,000 bottles, where marginal revenue equals marginal cost. So Jack's got that, they've done their calculations, and at 10,000 bottles, that gives them an average total cost of $13 a bottle. Average variable cost, again, it's 50,000 divided by 10,000 gives me $5 a bottle of variable cost, and fixed cost of $8 a bottle. Okay, questions on the setup? All right. So, how much money is Jack making? What is profit if market price of whiskey is $4 a bottle? What is Jack's profit? So write the profit equation down now. And tell me what you come up with there. So we've got a price of $4, quantity of 10,000, and then you've got this cost information. What is Jack's profit? I must be talking quietly at this point. What is Jack's profit? Negative 90, thank you. All right, so that one took so long, we better go extra credit point on that. I shouldn't have to wait that long. Thank you for cleaning that one up. Who was that? Let's see here. All right, how'd you get that? Dylan, right?
Yes.
How'd you get that?
Take $4 times the quantity, total revenue.
Okay, good. So let me do that here. Price times quantity minus total cost. And how'd you do it? Just 130, right? But you could think of $13 a bottle times the 10,000. So however, whatever information's given to you. So we got the total cost there of 130,000. So we end up with 40,000 minus 130,000 gives us a profit of a negative 90,000. Okay. Is there any other quantity that would make us better off? In this situation, is there any other quantity that could make us better off? I see some people who are listening, Holy Grail, blah, 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 that if we make a little less, if we make a little more, we're going to lose even more money. There is one unique case. There is one better quantity. This is one situation. That's why we're doing it now, to kind of call it to your attention. There is one better quantity that will maximize profits or minimize losses. Does anybody see it? What's that? Zero. Why? Zero is the oddball. Ike? Explain a little bit more, but I think you're on the right track. Awesome. That's right. Right? So remember, what defined fixed costs and variable costs was variable costs are tied to quantity, fixed costs are not. So if you shut down and produce nothing, it doesn't mean you're going out of business, but maybe business is slow that day, right? So the Chinese restaurant I know is closed on Mondays, right? So for whatever reason, maybe it's because they couldn't cover their variable costs. But it's better for Jack to produce nothing, and the loss will now be $80,000 instead of $90,000. So let's look at that. So note, if Jack shuts down, and this is the word we use, is down, so kind of get used to that. If Jack shuts down and does Q equal to 0, then my profit equation is total revenue of 0 because I produced nothing, minus my $80,000 of fixed costs. And so I lose $80,000. This is a better situation based on the numbers than this situation. So it's better to shut down. Okay, question on that so far? All right, so let's do another one here. If price equals $5, let's say Jack was fortunate enough, prices are going up, is the new article in the Wall Street Journal, whiskey prices have climbed from $4 to $5. $5. How are we doing now? 80K in the hole, right? So now we've got 50,000. So profits equal 50,000 minus the 130, and we're at negative 80. What should Jack do now? Either or. He's kind of indifferent, right, between shutting down or keeping it open. Now let's bring in a little dose of reality. If you were really running this business, think you'd stay open or close down? If you're really trying to put yourself in running a business and the issues that might be at play in the real world, do you think Jack should go ahead and produce the 10,000 and lose the 80 this way? Or is he better off losing the 80 this way by producing nothing? Making it? Why? Okay, so customer base, that might be something. Somebody other than Ike want to chip in? Yeah. Okay, losing employees, I think, is a potential big one, and maybe suppliers too, right? So we kind of brought up the corn mash. So we have a lot of other stakeholders, not just the stockholders, the owners of the company. The owner of the company maybe is kind of totally indifferent here. But if you have an ongoing business, I think at this point, the real world, you'd probably because keeping your employees working, they trust on you, they have a job or whatever. You'd rather be working it, and then of course with your customers too, at least hanging out there. So I think most real world business situations, you probably keep producing at this. All right, so what about $8? What if the price went to $8? Price climbed to 8. Yeah, so what's the, how much is the loss? 50. So our loss is 80,000 minus the 130 still. We're definitely wanting to operate, right? We're losing less money than if we shut down. So that one's crystal clear in this case. Is that sustainable in the long run? No. If we have persistent losses in the long run, then this would signal to us to go out of business, like stop doing business, to exit. So we made that short run, long run distinction. In the short run, it's a period of time in which at least one variable is fixed. But in the long run, you've had a chance to vary everything. And so in Jack Daniel's situation, has anybody been to the Jack Daniel's plant? Yeah? No? Nobody? If you get a chance to go, my brother happens to live in Louisville, so he's kind of on the, what do they call it, Whiskey Alley or something. That's not quite the right word, but there's a number of distilleries there, and Jack Daniel's is one of them, and it's a free tour. And if you're 21, you get a little bump of whiskey at the end, I think, if you want one. But it's freaking amazing to see the number of oak barrels. So they have these buildings out there, and all the whiskey stored for years, as you know, there's 8-year-old whiskey, 12-year-old whiskey, and that sort of thing. And so they've just got this, as far as the eye can see, almost going up in long ways of storage of whiskey in these oak barrels. So it's really cool to see that way. Even if you're not a whiskey drinker, it's kind of an impressive sight. So how long would this have to be before Jack would, change things up? Well, if he's had every opportunity for a couple years to get new barrels, to try new marketing efforts, to get new buildings, to get a new machine, to hire new people, to get new managers, and year after year after year, we just see this, it might be time to exit, right? So what do profits need to be at a minimum for companies to stick around for the long haul? 0, right? And remember, it's not all bad in econ class. Why? You're not losing anything in what sense? What drill down a little layer deeper. There's nothing else you can do better. So the opportunity costs of production are included in your total cost calculation. So you can't do better elsewhere. All right, so we get to that point. If the price climbs to $13, we are at this break-even quantity in the long run. So we get 130,000 minus 130,000 equals 0. All right, so we're going to kind of loosely draw this out now. So graphing this out, let's see, I do have this thing rebooted. Let's see if this stuff works. Yeah, when in doubt, reboot. Right. All right, here we go. And let me make sure I get this before we start squealing like a pig. Okay. So in our perfectly competitive market, we've got our average total cost curve, bowl-shaped, big fat dot. our average variable cost comes up and gets closer to the average. Big fat dot. Remember that vertical distance? What does that equal again? The vertical distance between the average variable cost and average total cost. What is it? All this stuff. Everybody's whispering. I think I hear the right answers, but be more brave. Fixed cost, right? Total fixed cost or average fixed cost? Average, right? So the sum of the averages equals the total. So average variable cost at this quantity right here is this vertical height plus the average fixed cost gives me the average total cost. So it's the sum of those three things equals the total. And then we've got that J-shaped marginal cost curve, which by definition cuts through the minimum points of both the averages. All right. So now I want to play a little bit of the game here with the perfect competition business. So at a price of $4, this is just kind of loosely related to that, at a price P1 of $5, if we're acting in perfect competition, the price is the demand curve for Jack's whiskey, right? This is kind of coming at you a little bit differently here, but we have remember the two graphs side by side, the market's over here, and the firm is a price taker, which we'll rehash this graph again later, but that's all I'm trying to do is think about the price taker business, and what's it equal to? What was the demand curve equal to? Because it's perfectly elastic, it's also equal to the marginal revenue curve. Marginal revenue curve. All right. Now, marginal revenue equals marginal cost at this quantity Q1. But if this is the situation, what should this company make? How many units should it produce if this is the circumstances for the company? They'd like to get there, but they are a price taker, so they take the price that the market gives them. The most that they can be getting is $4. So if they produce this quantity, they would be losing more money potentially, right? Because even if we do the marginal revenue versus marginal cost, all the way along here, each additional unit is more costly than the revenue it's generating. So that wouldn't be, we don't want to focus in on the cost minimizing quantity. The decisions are at the margin. But this is our special case. So if this is, I'm sorry, I kind of screwed this up. Maybe that's why you guys are being kind of flat. I was trying to loosely tie this to the case we just did, $4. That helps you out. Zero, right. So at a price of $4, the company should produce nothing, not this one. When I brought it up to $5, P2, let's call it, P2 is $5, that's associated with Q2, right? Marginal revenue, let's just start calling this MR2 and MR1. As the price goes up, what did we do in this situation? Did we produce 0 or Q2? Q2, this was this one. we started to say, oh, I get it. I'm kind of indifferent between 0 and that. That's my starting place. And then if I pick off P3 at $8, all firms maximize profit by producing the quantity where the revenue generated by the last unit is just equal to the cost of the last unit. So now I'd be producing this quantity. And we're still okay. We're kind of doing the $8 now. We're losing money, but we're still better off than shutting down. And then finally, once we get up to P4 at $13, obviously this isn't drawn to scale very well, then we produce Q4. And then let me add on a couple more here. At P5, maybe just one more. At P5, at this price, the marginal revenue is MR5. Marginal revenue equals marginal cost here. And now we're actually making positive economic profit. All right, so make sure you have an X here. I'm just going to erase this just so it's gone. If you crossed it off or if you want to erase it, you can. I just don't want that to come into play here, because at this price, we're really going to produce 0. If price fell down to here, we produce nothing, nothing, nothing. If price was here, we'd produce here, 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 here. As price goes up, so at this price, I produce this much. 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 What is that starting to sound like? It doesn't sound like a marginal cost curve to me. What is it? I'm a producer, Jack Daniels, making whiskey. At this price, I'll produce this much. At this price, I'll produce this much. What is that thing? Something curve? I didn't hear what production curve. I got a better word than that. The curve I like. So let's see. At this price, I will supply this quantity. At this price, I'll supply this quantity. Right? Once I use that supply word, you guys got it. So the marginal cost curve indeed truly is the supply curve. It shows a relationship between market prices and the quantity supplied. Now here's where it gets a little funny though. At this price, I produce this much. At this price, I produce this much. At this price, I produce this much. So the supply curve is actually this squiggly line all the way up to there, and then it jumps at that break-even point. This is the supply curve. So marginal cost curve equals supply when price is greater than or equal to average variable cost. Remember, this is my average variable cost curve. In our example we did with Jack, that was at $5. So as soon as price got up to 5, we were making whiskey, right? We were back in the market making whiskey. And so the supply curve is that chunk of the marginal cost curve. All right, so questions there? So how can we verbalize that? Maybe it would be even helpful when you talk to your friends who run a business. If you're going to be open, make sure you cover your fixed cost or variable cost. Variable or fixed? I heard a fixed, I heard a variable. So let's write that out and then we'll choose little bit. So key point. If you are going to produce something, if you're going to be open for business, make sure you expect to cover, make sure you expect to cover blank. Make sure you cover, and that's where I want to insert, are we covering our variable costs or are we covering our fixed costs? What are we covering? Fixed? What do you guys think back here? Even something from this side here. So, what do you think? Cover fixed or variable? Fixed? Variable? Look at this. It's not the same table. We got different answers. Getting close here. Fixed or variable? What are we covering? I hear more variables. How many people say variable? Show of hands. How many people are in the fixed camp? Show of hands. Ooh, I think the fixed camp might have. Let me think about this a little differently. Suppose, how many of you have a little, maybe small town bar that's pretty much one bartender? I think there's a couple of them here in Ottawa, back at your hometown, where it's just one bartender, they're open late, and it's just that person. When should you close down? In other words, when should you call it a night? Maybe you have the liberty of some of these small town bars, they kind of choose when to close down. It might be 10 o'clock, it might be 2 a.m. When would be the rational time to close down for the night? And let's put a little more meat on the bones here. I heard lots of people going, that's good. Suppose the person's making $10 an hour. So the bartender, they're kind of a bartender manager person or whatever. They get tips on top of that too. So, but suppose the bartender's making $10 an hour. At what point would it be a good idea to just shut her down for the night? Yeah.
When it's not worth your time.
Okay, it's not worth your time. So what do you need to cover in my little bar situation? What's the minimum amount of money that you need to sell in drinks to make it worth your time to stay open? The $10, it's not quite everything else. Cost of the alcohol, yeah, not the fixed cost, not the rent, but the cost of the alcohol. So if you're pouring a Captain Coke, whenever that shot of Captain, and good bars have that all priced out, right? They have a jug of Captain Morgan, and each one's priced out, and then you've got the Coke off the gun. You know the cost of a drink, or you should if you don't. A lot of them don't, by the way, but especially small town ones, but they kind of got it roughly figured out. So if there's 50 cents into the drink, then I need to cover that. If we've got a $4 Captain Morgan special tonight, and I've got 50 cents into the glass and those materials directly related to the drink, how many customers do I need to make this venture work? How many customers do I need to make this venture work? If I've got a $4 drink, 50 cents worth of cost, by the way, that didn't include the labor. So this was just 50 cents worth of booze and mix. 3 people?
Yeah.
So 3 people sounded kind of good, right? At 3 people, we'd have $1.50 worth of drink costs, and we'd be clearing $12. So let's just say we're clearing $10, which covers my bartender too, right? So what are we covering? Variable costs or fixed costs? Variable costs. As long as you can cover your variable costs of production, then go ahead and open. Stay open. And we kind of see that jump out here. Now that we're getting to know some of the terms and some of the lingo, the price per unit in the average variable cost per unit, right? This is where it kicks in and all of a sudden we're in because we're covering our average variable cost. So there's a good chance you get like a test question or a homework question related to that, and that's often hard because we know we got this fixed cost, variable cost, and a lot of people just their gut feeling says fixed cost, which you guys reflected. More of your hands were up for fixed cost, but it's actually the variable cost. Try to remember that little bartender story that we need to cover those variable costs to make sense to be open. Now, if we have more people show up, people bring their buddies, and instead of 3 drinks, we sell 6 drinks. Now we're starting to pay a little bit towards our rent payment, right? We might not be making money yet, but we're starting to contribute to our fixed costs at that point. So as we start to get into this $8 range with this example, we've covered all of our variable costs. By the way, remember, let me be clear on this. At Q3 and P3 at $8, our average variable cost is the height of that squiggly, right? I go up to the average variable cost curve, hang a left, read off that number. I'm covering that much, but then look at what I'm able to do. I'm able to cover this much of my average fixed costs. My rent and my cooler and my electricity and those other types of fixed costs is that vertical height. And so I'm chipping away at part of that. So that's working to the good. I'm losing less money by staying open. Okay, any last questions or comments there? All right, so make sure you expect to cover your variable cost. Total variable cost for that time period. So make sure you add on this time period for it's a year or a day or a week or whatever. And then put in parentheses what we did up here for the supply curve. Price needs to be greater than or equal to average variable cost. This expression is saying that verbally, that you're covering the bartender and the material cost of the drink. The price that you're selling at is greater than or equal to the average variable cost. All right, so our holy grail business, turns out you were lied to. Not the first time that I might do that. This is one of the bigger lies that I tell. So when we did the whole how does firm maximize profit, by producing the quantity where the revenue generated by the last unit produced is equal to the cost of the last unit, true if what? Price is greater than average variable cost. Otherwise, produce 0. Shut down. Right? So that's a slight modification. In other words, the holy grail business that works, but it's only over this chunk. Otherwise, produce nothing. So, modified profit maximization. So let's call it the full profit max deal. If price is greater than or equal to average variable cost, then Q star, produce the quantity where marginal revenue equals marginal cost. If price is less than average variable cost, then do Q star equal to Zippo, which we call shutdown. You're going to shut down and just absorb your fixed cost at that point. Because the fixed cost you got to pay no matter what. All right, so that brings to a close our theory of Jack Daniels. All right, so now we're going to get back to the full-blown model. All right, everybody cool on this before I erase? No? Raise your hand. Do you still need time? Over here. Okay. I'll start over here. All right, so we're going to play on a little bit of movement in perfect competition. And look at the adjustments. So long run adjustments / predictions for perfect competition. Okay, so we're going to put the big enchilada up here. Two graphs side by side. Make sure you draw them kind of nice and big for yourself. The chapter 3 market is the one off to the left, where we're measuring big Q. And we've got some sort of demand curve, some sort of supply curve, just doing our home base. Some sort of initial equilibrium price and equilibrium quantity.
What is PC stand for?
Perfect competition. Usually put perf comp, but I didn't this time. So yeah, always ask me if you see something like that you don't get some of my shorthand. And then off to the right is our representative firm. So put a little q. This is the market. And this is the representative firm. That was Farmer Dick, Farmer Tom, Farmer Harry. It's just kind of the average participant in the market. Each one of them being relatively small to the total output of the market, a drop of water in the bucket, right? So the representative firms drop it in the water in the bucket, which makes them a price taker. They have no market power. What were the 3 characteristics of perfect competition? What's that? Lots of firms. Yep, the drop of water in the bucket thing. So that was one of them. Homogeneous product. Good. What did that mean? Same products, identical products. They're really perfect substitutes. Good. And lastly, free entry and exit. So it's pretty easy to start up a business or to leave. And so under those conditions, the firm has no pricing power. They are a price taker. So we connect the graph to the left and the graph to the right with the firm, it representing their demand curve, which is equal to their marginal revenue curve. And then we've got some sort of J-shaped marginal cost curve because the firm cannot escape the law of diminishing marginal product and therefore leads to the law of increasing cost. So I titled this long run adjustments. So if we're initially in a long run equilibrium, how much money is the representative firm making? How much? 0. Right? So our prediction last time was that the firms in perfect competition would have 0 economic profit, which sounds a little depressing at first. But again, they're covering all of their opportunity costs, so it represents a fair return to the resources that are being used in the production of their good. All firms maximize profits by producing the quantity where the revenue generated by the last unit is equal to the cost of the last unit. So in this picture, that happens. Those 2 lines cross each other here, telling that the profit maximizing quantity is that amount. I'm not going to muddy the waters by putting the average variable cost curve in here, but it would be there. So sometimes that'll be in your graph and sometimes it won't. Don't let that freak you out. And that's it. So this is our initial situation for a long-run equilibrium. All right, now let's shock the system. So let's see. Example. Suppose the milk market is initially in a long-run equilibrium. If the FDA announces new research that milk drinkers live longer, what is the short run and long run effect of this news? So suppose the milk market is initially in a long-run equilibrium. If the FDA announces new research that milk lives longer, milk helps you live longer, helps humans live longer. What is the short-run effect and long-run effect? Okay, so let's start with Chapter 3. Impact of FDA announcement. Increase in demand, right? So we've got the buyers of milk have new incentive to buy some milk. So that's our first step in the chain. So an increase in demand curve shifting to, let's call it D2 from D1. Prediction on price, increase in price. Prediction on quantity. Quantity in the market goes up or down? Up. So we bump up to Q2. Why did that happen? Why did the Q2 go up? This was Chapter 3, we'd be kind of done here. But now we're telling this story about individual companies and their behavior. What did they do over here? What happened with the representative firm? Price went up, so their individual quantity went up, right? So that's what this picture is showing is if milk prices climb, they're going to bump up their production because they can make more money doing it. So their profit maximizing quantity has changed from Q1 to Q2. So they've reacted to the news. They've increased the quantity supply. All right, what else can you tell me about our little picture? What's going on with this result? Let's focus in on this side, on the representative firm. What else can you tell me about what's going on for the representative milk dairy farmer over here. Average total cost, what? Increases. So average total cost snuck up on it, right? So at this quantity, you go up to the average total cost curve, hang the left, read off that number. That's higher than what it was at Q1. So average total cost has increased. Good. What else? Marginal cost, the cost of the last unit of milk produced is higher than what it was down here. Okay, good. What else? They're making a profit. That's a big one. And how much profit are they making? What's the profit equation? Total revenue minus total cost. Do I got enough information up here to show the profit graphically? Hearing some no's? Ashley, you were the one to mention you want to come up and do some coloring? Just like grade school, kindergarten class. Good to play with colors. Yeah. What would represent their profit? Okay, stop. So you're doing that triangle? Okay. No. But thank you for playing. I'll give you an extra credit point for helping us proceed this thing along. But that is not right for the profit. Who else wants to come up? Hunzi, I don't want to leave you out of this. Do you want to show, or you got the figured out, or no? Okay. So who's got the profit area? Who's ready? Let's use the green marker. Dylan, on track? Okay. Come on up. Yeah. No. Nope. That's cool. Yeah. Hunzi, you want to do it? Yeah. Let me, oh shoot, I don't have you logged in. It's gonna shine. All right, let me see what you got. Go ahead.
Okay. Well, I didn't draw it yet, but it's gonna be on
I
this
just had
side
an
at the bottom square.
Okay. Go ahead. Let me see what you got. Go ahead.
Well, it's gonna fall into this bottom areas right here.
Oh,
See where
oh man, I'm ruining this. All right, there we go. Now I got you. Say it again. There, perfect. One more time. I just didn't have the video. It was my fault.
Okay. It's gonna fall on this line is the triangles on the bottom part.
Can you show me on the other side, off to the right, for the firm, for the company? I want to see it on the company side.
Oh, on the company side?
Yeah.
I think it's gonna. Did you see the video?
Yeah, you should.
Okay, it's gonna be in this area with the triangle shape.
Okay. No, that's not right. Draw your demand curve. Draw your demand curve. But thank you. Okay. Anybody else? Somebody's got to get this thing. All right. I see you. Go ahead. And then do what Dylan did. Kind of show me the area. No. Nope. Anybody else? So what I'm learning is I need to nurse this along a little bit more here. All right. So and what you guys do that's you're not using enough goggles So you might want to flip around a little bit. Let's put on our equation goggles for a second. You guys said it and you memorized total revenue minus total cost really well, but let's look at the profit equation. Profits equal total revenue minus total cost, which I heard many of you say. How else can we express this? What's total revenue? Price times quantity. So let's do that one. Price times quantity. I'm going to put little q since we're talking about the company now. Price times quantity minus average total cost times quantity. Okay, and then what could I do with the little math here? What was our trick? We could pull Q out. So price minus average total cost times quantity. Price in this case is P2, this higher price, and then we've got the average total cost. Tabitha correctly pointed out that the average total cost, you go up to the average total cost curve, hang a left. Average total cost is that number. The price, I'm a price taker, so the price is P2. Starting to see it now? What quantity are we producing? Q1 or Q2? Q2, right? So we got price minus average total cost. Price minus average total cost would give you that distance, times the quantity produced, which is this horizontal distance. There it is. Right? All right. So we got a little bit of work to do, but that rectangle represents the economic profit for the representative firm after the announcement of the milk deal. Demand went up, driving market prices up. The individual dairy farmers responded by producing more quantity, and now each one is earning this economic profit of the red rectangle area. All right, did everybody get this part? I think there might be another way. If your brain wasn't quite clicking, you need to especially watch me on this one. Let's do this one. Total revenue, price times quantity. Let's throw in a quantity of 120 and a price of, I don't know, $10. $10 times 120, $1,200. Price times quantity would be the area of this rectangle, this big one right here. Right? Total revenue minus total cost. What's total cost? Of producing 120 units, I go up to the average total cost curve, hang a left, read off this number. Let's just say it's $8. Average total cost times the quantity, total cost. That rectangle. Total revenue minus total cost gives you profit. That way of looking at it, if your brain kind of works that way. So we've got the, first of all, you got to know your equation goggles, because you can't really start doing these areas unless you've got your equation goggles down. So you got to have this memorized, but you can work through that triangle even with this top level. So you can kind of go either way on it. All right, questions on that? All right, so have we fully answered the question? What is the short run and long run effect of this news? That's the short run. Good. Why do you say that? Because what? Something's still fixed, yeah. So what's going to happen when there's economic profit being the average dairy farmer. More dairy farmers are going to come in. Now, in order to start a brand new dairy business, how many resources do you need? If you're brand new, brand spanking new, lots of them, you need all of them. So in the long run, we have the opportunity to vary all resources. In the short run, something's fixed. So I want to think about that in relationship to this because that's why this is happening. We can't have entry in the short run. In the short run, we're stuck with the existing firms. Those existing firms, because of the resources they have at their disposal already in place, are ramp up dairy production for us, right? So the entry of firms is what starts off the long run effect. So at this point, the short run effect is done. If I had just asked you what's the short run effect, this would be it. So let me summarize the steps so far so we can add on to it nice and slowly. So, steps to the process. Steps for long-run adjustment. Step number 1, long-run equilibrium. That's what we started off with. Step number 2, there was a demand shock. Could be a supply shock, by the way, but some sort of demand or supply shock. That's the shock to the system. All those shifters that we had other demand shifters, other supply shifters. Something disrupts ceteris paribus, demand or supply shock. In this particular case, I had a positive demand shock. So from our example, there's an increase in demand, a shift to the right. Number 3, the increase in demand bumped up market prices. So there's an increase in P star and an increase in big Q. So if we had 100 units beforehand, and over here, this was 100,000 units. Big Q is 100,000, little q is 100 in our initial long-run equilibrium. You'll probably see a homework test problem like this. How many companies are actually in this market right now? 1,000? How'd you get it? 100,000 divided by 100? 100,000 divided by 100? All right, get rid of these zeros, and we're left with 1,000 companies. So there's 1,000 companies here, and we can kind of get that connection through our other equation of, remember, big Q, the quantity in the marketplace, is equal to the sum of the Qs. I equal 1 to n. If there's 1,000 firms, and this is the average production, 1,000 firms, each producing 100 units, gives me 100,000 units in the market. All right, so 1,000 firms doing this, so we've got an increase in price, an increase in market quantity, right? Step number 4, that led to an increase in marginal revenue for the representative firm, the shift up to MR2, and an increase in little q, the amount that they're supplying, which is our bump up to Q2. So what is Q2? Given the information that I just told you already, what is Q2? 120,000. So because we're in the short run, there's no entry of firms allowed or able to be done. And so we still have the same 1,000 firms, but each one has bumped up their production to 120 units, which means we've got 120,000 units in the market. The same 1,000 firms. All right. Step number 5. Economic profits are greater than 0. We have positive economic profits. That's our red box. Okay, so if you draw on this, this is the short run effect. So up to step 5, 1 through 5 is the short run effect. All right, you're in trouble if I'm pulling out the golf club. Long run effect. I think in special danger here. These guys are out of reach, but I could get a little careless over here. So, long run effect, we've got economic profits. Economic profits, what is it signaling? Enter me, enter me. How do we model that graphically? Supply shifts to the right, number of firms, right? So one of the supply shifters was the number of firms. Shifts to the left, to the right, prices start to fall, so more firms entering, prices starting to fall. When does it stop? When profit gets back to 0. That was the condition that stops it, right? If it goes too far and there's losses, then there would be exit. But as soon as the resources being used have just normal profits, then new companies are going to flock to other ventures. There's nothing special about the dairy industry in particular. They're just right at the normal profit. All right, so what price do we end up at? The first price, the initial price, right? Because at this price, the representative firm had 0 economic profit. That's where we stop. So we can kind of cheat a little bit and show that it go to right there. So you can kind of work this thing backwards a little by saying we're going to get back to where we started. There must be a new supply curve, S2, that's going to be to the right of where it was before. So price is the same as it was before. Let's call it P3. It's really back to P1, but just to kind of tell this dynamic story. What's happened to market quantity? It's gone up. Right? So we were back here, but now we're here. Q3 is bigger than Q1, but wait a second, we're back to Q1 over here. Where did we screw up? We got more producers, right? So we have more firms. The average firm, the red firm, is still back to where they started, but there's more of them. So we can see how many companies actually came in by looking back to 100. So if we had this thing climb to 130,000, let's say, how many companies are in the market? How many companies are in the market? Well, 1,300. How'd we get that? There's 130,000 units. The average company's making 100, right? So 130,000 divided by the average production. Each firm on average is now producing 100. Knock off those zeros, there's 1,300 companies. So our end result in the long run is that we have 1,300 companies where we started with 1,000 companies. However, each company is back to earning just a normal profit, economic profit of 0. So we get right back to Q1 for each one. Okay, I know I've thrown a lot at you. Questions? I'm going to summarize it a little bit more, but if you got the detail that you're just a little froggy on, is this going to be on the test? Not this one Wednesday, no. But your final, yes. So with that being said, knowing that you're going to get tested on it, are you sure there's no questions here? This is a lot of info. Dylan?
I'm just going to ask, is the final everything, or will it start with this?
Well, that's kind of a loaded question. Let me answer it this way. Do you think you could answer this question by jumping into chapter 12? No. Chapter 3, right here, right? So in a sense, the test is cumulative by nature because we've been building on to our toolbox the whole way. But to more specifically answer your question, it will be on just the material of that section. But it really does build on itself, so you'd be pretty much screwed if you just jump in on the second half of the course. Okay, any other questions about the model? All right, so let's add on here. Step number 6, we start our long run effect here. Step number 6, we had entry of firms, right? The economic profits lead to entry. I'm going to start step number 6 here just a moment. Step number 6. So entry due to economic profit greater than 0. And that means an increase in the supply curve. The increase in supply leads to a decrease in equilibrium price and an increase in market quantity. That was this part, heading towards Q3 as we're, so kind of our path that we traveled is we went up to here and now we're coming down to here due to the entry of firms. So step number 7, as that price starts to fall, you can see these profits being squeezed out. Right? As the prices start to fall, we start to shrink that box. Profits start to fall. And they ultimately go back to 0, yes. So a decrease in price, the increase in supply for the firm, for the representative firm, a decrease in price leads to a decreasing marginal revenue, and they respond by decreasing their equilibrium quantity. So number 8, that price is just going to keep falling until we get to economic profits of 0. So the increase in supply continues until economic profits are back to 0. So the representative firm is back to where we started. Back to where we started. And that, once again, last step, gives us our long run equilibrium. So the journey we started with a long run equilibrium, and then we moved back to the long run equilibrium, which is where we expect to be, economic profits equal 0. Let you guys get caught up. All right, so this situation is one of three possible cases. One of three possible cases. The one we did is called a constant cost industry. So a key point to add to the end of your steps here, key point. This is the case for a constant cost industry. This is the case for a constant cost industry. There's also an increasing cost industry and a decreasing cost industry. So let me give you a little bit different story to kind of back this idea. So costs stayed relatively constant while the market was changing. So in other words, as the market was expanding from Q1 to Q2, costs stayed the same. That's what we mean by a constant cost industry. So what do you think might happen if an industry was expanding to cost? What would you expect might happen to the cost of the company if an industry is going through an expansion for their product? Thoughts on that? Costs go up? What did you say? Costs? Our result that we got here is that we had more product being produced. So let me bring you back to Henry Ford. What did Henry Ford make? Cars. All right. So we had this infant automobile industry that started off, right? As cars started to become more and more popular, partly due to what Henry Ford did, which he was able to bring costs down through the assembly line process, right? So that was one of his bigger contributions. But beyond that, what are some pieces that are needed on cars, even those old, since we just had the classic car show, which was pretty awesome, by the way, if you haven't had a chance to see that. What's that? Wheels and the tires, right? So like, let's take the rubber on the tire. So when the car industry is in its infancy, was there a lot of rubber tires around that fit cars? No, right? We had bicycle tires and stuff like that, but nothing that was specific to a car. And so what do you suppose happened as the car industry started to get bigger and bigger and bigger? More and more tires they had an automatic buyer for the tires because the industry was exploding. What do you think happened to the average cost per tire as the tire industry was able to also then expand? Probably decreased. Due to what factor? The quantity. Quantity went up, average costs go down, potentially, not always as we learn. What did we call that though? Who remembers that one? As you increase quantity and you find that your long run average costs fall, economies of scale, one of our key concepts to remember, economies of scale. So if there's economies of scale, then that might allow the company to make a big factory for tires, right? And they can process more rubber into tires and steel belted radials and blah, 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 blah. And so whatever it cost initially, maybe they're able to provide at a lower cost now. So the other case we have is a decreasing cost industry. A decreasing cost industry. And I want to come back to our picture to try to visualize what would be happening in a decreasing cost industry. As the expansion is going on and there's more firms entering the market and the market quantity is getting bigger and bigger, so as the supply is increasing, the costs are falling. How would you reflect that in this model? How would that be reflected potentially? Price was going down due to the market effect, but I want to hang on costs. Where do we got cost up here? Average total cost, right? So some of that would be changing. It has variable cost and fixed in it, right? So if costs are falling, what would be probably the appropriate thing to do here? Shift it down, right? So now as entries coming in a decreasing cost industry, costs might be starting to drift down. So what happens if that's the case for market prices? Try to visualize that. I should have even got my golf club going. So we got this going this way, this starting to drop. Price is going to fall, right? So the price of the product, remember, is going to ultimately fall. We're going to see the benefits of the economies of scale in the tire market with my example. Costs are falling, ultimately will lead to not crazy profits being made by that doggone Henry Ford, but rather entry into the automobile market, eventually getting to the point where all automobile makers are making a normal profit. So our prediction is the same. With healthy competition, we will get back to profits being equal to zero, but it ultimately might be at a lower market price. All right, so let's add that one before we do the next case. Your textbook has some pretty pictures of that. I'm not gonna do that more than what I just gave you with my hands and the golf club, but I am gonna modify your steps of where this new thing comes in. So my last note to you was that was a constant cost industry. So for an increasing cost, I'm sorry, decreasing is what we did. We'll come back to that one in a sec. For a decreasing cost industry, the key is that there's a decrease in average total cost when supply increases. That's really the bottom line. This is like a shift down of the average total cost line. It's going to fall, which is nice. It's going to decrease, kind of going with the language that we got here. So we're going to get that happening, which is on, I just kind of made up those steps as I went. I see the steps. So step number 6, I guess. Yes, step number 6, you would add this. So this is kind of 6B. This is going to be happening on your steps. Right away when the supply curve is shifting, this is going to be happening. And then we still get the end result. In the long run effect is that the new equilibrium price, so the new price is less than the initial price. All right, so questions on that? And then if you want to write a little note to yourself, see figures in my Econ Lab, which is also your textbook. There's figures in there. They've got some nice, pretty pictures. I don't think I brought my textbook today, or I'd throw them up there. All right, so to motivate this too, let's put on an example. Decrease in the cost of as the auto industry expanded. A decrease in the cost of tires as the auto industry expanded. Just to kind of remember what we did in class, if you can look back to it. So for an increasing cost industry, increasing cost industry, the story is just the opposite. As the industry expands, the cost of production goes up. So maybe we've got a furniture industry, the market for wood furniture. And as the industry starts to expand, we start harvesting more and more trees, and we start depleting the inventory of oak, right, in the forest. And you can't just build an oak tree like that. So as the oak furniture market expands, perhaps there's something going on with the tree market that's driving up oak prices, right? So the industry's expanding, but the cost per board or the cost of the raw materials is starting to go up on us because of that expansion, whatever those circumstances were going on there. And so back to our graph here, to visualize that, as the industry expands again, as the supply curve starts to shift to the left, average total costs now are going to go the other direction. They're going to start to drift up on us. And so what's our prediction of what's going to happen with the price relative to our initial starting spot? It'll go up. It's going to meet somewhere in the middle. So now we're going to be here. We're still going to be economic profits equal to 0, but our ending price is going to be somewhere a little bit higher. So increasing cost industry, our key point is that there's an increase in average total cost, a shift up when there's an increase in supply. Entry continues just like it did before until economic profit equals 0. That's always our thing, but long run price will be higher than initial price. All right, so the thing we can do, let's see, what color should I do? Green. We can derive the long-run supply curve here by connecting the dots of the long-run equilibrium. We started here, so if we kind of put a big fat star there, that's our initial situation. And we ended here in a constant cost industry. What if the demand curve would have been here? What if there was a negative demand shock? The economy goes into a recession, causing average incomes to fall. Let's walk through that mentally here. Price goes from our starting place now, remember, I'm not starting over here, start back here with our original supply and demand. So instead of D2, let's suppose we've got a demand curve shift here. Price goes down, quantity goes down. What's happening to our representative firm? He's producing less. Economic profit is negative, it's a loss. So if that's consistent and nothing else changes, what's going to happen if there's losses for the representative firm for a long period of time? Go out of business, exit. Now check this out. As the demand curve shifts down and now there's exit, what happens to price? It rebounds and comes back up. So the exiting of firms, when are they going to stop? When economic profit's zero. That answer is always the same, and that's going to happen right here. And so whether we did a demand curve shift out to here, 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 we always end up back to where we started in a constant cost industry. And so this is also called the long-run supply curve. The long-run supply curve is perfectly elastic in a constant cost industry. All right, that looks like a good spot to end. Yeah, so I wore you out today. That was a good workout, good mental workout. Way to work your brains. I'm proud of each and every one of you. Those of you who are still here that didn't pass out. Yeah.
Are you gonna email us the study guide?
Question, Hunby?